Girly. In today's video, we're going to talk about function. Functions in real life is a course of action compelled by a specific purpose. For example, the function of the eye is to let the beholder see. In mathematics, functions are representation of many input and output. Furthermore, function relates or connects this input and output. Inputs are group or sets of data. It could be numbers which are infinite, or letters and shape which could be considered as finite. In the other hand, output is the resulting product of the input. To understand function, let's look at this example. So, we have here an example of algebraic function. Y equals 2x. First, let us identify the input and output among the variables. What do you think among the variables is the input and the output? Correct! Y variable is the output, while X variable is the input. Moving on, let us assume that input value of X is 0. What do you think is the output? If your answer is 0, then you're correct. How did we get the answer? The answer is obtained by substituting the value of X to the algebraic function. Hence, y equals 2x becomes y equals 2 multiplied by 0. So, the answer is 0. We have here our function. G of x is equal to square root of 2x squared plus 1 over negative 3x squared plus 2. Find y if the value of x is 1/2, negative 3/4, negative 5, and sine x. First, let's find out the value of y using x equals to 1/2. Step 1. Substitute 1/2 to the x variable in the given equation. Thus, we will have g of x equal to 2 multiplied by 1/2 squared plus 1 over negative 3 multiplied by 1/2 squared plus 2. Step 2. Multiply the equation. We will have g of x equal to square root of 2 multiplied by 1/4 plus 1 over negative 3 multiplied by 1/4 plus 2. Step 3. We will make the equation simpler by simplifying the function. We will have g of x equal to square root of 2 over 4 plus 1 over negative 3 over 4 plus 2. And the resulting answer of the last equation is g of x equal to square root of 1 multiplied by 1/2 over 1 multiplied by 1/4. Then, step 4. Convert mixed number into improper fractions. Then, we will have g of x equal to square root of 3 over 2 over 5 over 4. By then, we will be able to get the quotient, and the final answer will be g of x equal to square root of 6 over 5. Let's proceed to the next value. If x is equal to negative 3/4. Following the step in the previous solution, substitute negative 3/4 to the x variable. We will have g of x is equal to square root of 2 multiplied by negative 3/4 squared plus 1 over negative 3 multiplied by negative 3/4 squared plus 2. By simplifying, we will have g of x is equal to square root of 2 multiplied by 9 over 16 plus 1 over negative 3 multiplied by 9 over 16 plus 2. Next, we will simplify the equation. We will have g of x is equal to square root of 9 over 8 plus 1 over negative 27 over 16 plus 2. Next, we will simplify the fraction in the whole number. We will have g of x is equal to square root of 17 over 8 over 5 over 16. And the final answer will be g of x is equal to the square root of 34 over 5. If the value of x is negative 5, by substitution, we will have g of x equal to square root of 2 multiplied by negative 5 squared plus 1 over negative 3 multiplied by negative 5 squared plus 2. Then, we will simplify the exponents. Thus, g of x equal to square root of 2 multiplied by 25 plus 1 over negative 3 multiplied by 25 plus 2. Furthermore, we will simplify the whole numbers following the operation accordingly. Hence, g of x equal to square root of 50 plus 1 over negative 75 plus 2. Lastly, we will have the final answer. G of x equal to square root of 51 over negative 73. If x value is equal to the trigonometric value sine x, we will have g of x equal to square root of 2 multiplied by sine x squared plus 1 over negative 3 multiplied by sine x squared plus 2. By distributing the exponent, we will have g of x equal to square root of 2 multiplied by sine squared x plus 1 over negative 3 multiplied by sine squared x plus 2. By simplifying the equation, our final answer will be g of x equal to square root of 2 sine squared x plus 1 over negative 3 sine squared x plus 2. Since we have tackled the concept of function, we will proceed to the idea of limits and continuity. What is limit? Limit allow us to know what value will the function approaches based on the input. Let's explain it using analogy. Suppose you are craving for a pizza. Fortunately, there's a pizza in the fridge. If someone will ask on where you will go, they would say you will approach towards the fridge. It's the same thing we want to do with function. You will take the limit of the function you describe where they're going. Let's see an example with this function. F of x is equal to 3x squared minus 1. With this function, I'm really curious what value the function approaches. If I use x value closer to the number 2, let's see by using these inputs like 1.9, 1.99, and 1.999. When I use this, I got values like 9.83, 10.8803, and 10.988003. From this value, the function approaches to 11. So, we say the limit of the function as x approaches to 2 is 11. We have here a complex function. We need to solve for the limits. We will have limits of 1 over 6 plus 1 over x over 6 plus x approaches to negative 6. Step 1. We need to substitute the value of x, but we just leave the numerator. We will have limit of n over positive 6 minus 6 x approaches to negative 6 is equals to n over 0. So, our limit is 0 or undefined. So next, we need to use algebra technique to simplify the complex fraction. Step 2. Simplify the complex fraction. In our numerator, we will use addition of the fraction. We know that a over b plus c over d is equals to a multiplied by d and c multiplied by b over b multiplied by a. We will use this principle to solve for the numerator. So, if we have 1 over 6 plus 1 over x, we can have limits of 1 multiplied by x plus 1 multiplied by 6 over 6 multiplied by x. In our denominator, 6x, x approaches to negative 6. Step 3. We will modify the equation. And we need to reciprocal the denominator. We will have limit of x plus 6 over 6x multiplied by 1 over 6x, x approaches to negative 6. You know that our numerator is identical, so by algebra, we can cancel the x plus 6 and 6 plus x. So now, we have the simplest complex fraction, which is 1 over 6x. Lastly, step 4. We need to substitute negative 6 to the x variable to get the limit of x approaches to negative 6. We will have limit of 1 over 6x is equals to 1 over 6 multiplied by negative 6 is equals to 1 over negative 36 x approaches to negative 6. The final answer will be limit of 1 over 36x approaches to negative 6. A derivative is a way to show instantaneous rate of change, that is, the amount by which a function is changing at one given point. The derivative is often written as dy over dx. The derivative of y with respect to x is defined as f of prime a equals to limit of f multiplied by a plus h minus f of a over h as h approaches to 0. In this example, we need to find the derivative of the function. We will have f of x is equals to the square root of 2x plus 3 raised to 5 minus 7. So, let's get started with our first step. The first thing I like to do when taking a derivative of square root is 1. Get rid of the square root. And this could be done very easy by rewriting square root as 1/2 exponent. Let us read the function. We will have f of x is equals to 2x plus 3 raised to 5 minus 7 raised to 1/2. So now, you notice that we have big parentheses followed by the exponent of 1/2. This means we have to use chain rule to take the derivative. Parentheses followed by exponent is clear indication we have to use chain rule to take the derivative. So, when taking the derivative, we always have to take the exponent and multiply it in the front, and our new exponent is always subtracted by 1. We will have f of prime x is equals to 1/2 multiplied by 2x plus 3 raised to 5 minus 7 raised to negative 1/2. So now, at this point, we're ready to use chain rule. So, what is chain rule? Chain rule says we need to multiply everything by the derivative of the inside of the parentheses. So, how do we take the derivative of d over dx is equals to 2x plus 3 raised to 5 minus 7? Once again, we have parentheses followed by the exponent of 5. So, we have to use the chain rule again. So, let's take the exponent of 5 and multiply it in the front, and then our new exponent will be subtracted by 1. So, we will have f of prime x is equals to 1/2 multiplied by 2x plus 3 raised to 5 minus 7 raised to negative 1/2 multiplied by 5 multiplied by 2x plus 3 raised to 4 minus 7. And then, we will multiply everything by the derivative of the inside of the parentheses to use the chain rule. So, we're gonna multiply all this by the derivative of d over dx is equals to 2x plus 3 minus 7. Before we forget, we still need to get the derivative of our negative 7. The derivative of negative 7 is equals to 0. So, we have f of prime x is equals to 1/2 multiplied by 2x plus 3 raised to 5 minus 7 raised to negative 1/2 multiplied by 5 multiplied by 2x plus 3 raised to 4 multiplied by d over dx is equals to 2x plus 3, and this could be simplified even further. We still need to take the derivative of 2x plus 3, and the derivative of 2x is 2 and the derivative of 3 is 0. So, we have f of prime x is equals to 1/2 multiplied by 2x plus 3 raised to 5 minus 7 raised to negative 1/2 multiplied by 5 multiplied by 2x plus 3 raised to 4 multiplied by 2. Next, we need to multiply 2, 5, and 1/2, and we will have f of prime x is equals to 5 multiplied by 2x plus 3 raised to 5 minus 7 multiplied to negative 1/2 multiplied by 2x plus 3 raised to 4. Next, we need to get rid with the negative exponent. We need to use the property in algebra which says that negative exponent in the numerator is a positive in denominator, and we will rewrite positive 1/2 exponent in the denominator. Lastly, we need to change 1/2 exponent back to the square root. So, our final answer is f of prime x is equals to 5 multiplied by 2x plus 3 raised to 4 over square root of 2x plus 3 raised to 5 minus 7. Did you learn something? Great job! See you in our next video.